Performing a transformation simply means moving the function around on the coordinate plane. There are three types of transformations that we cover. The first is translations, where you're sliding the function either left and right or up and down. The second is reflections, where you're reflecting the function across the x-axis. And the third is dilations, where you're either stretching or compressing the function. What's nice about these transformations is they appear in the same place on any equation that we cover in Algebra 1 and Algebra 2. So it's nice and consistent the whole way. If your number is in front of the equation, represented by a here, then there's two possible transformations happening. If the a is negative, that's reflecting the function across the x-axis. And if the a is a number greater than 1, it's stretching the function. And if the a is less than 1, so a fraction or a decimal, then it's compressing the function. Second, if your number is with x, represented by h here, then it's translating your function either left and right. And if your number is at the end, represented by k here, then your function is translating up or down. Again, these are the same transformations that appear in any equation and function that we cover in Algebra 1 and Algebra 2. So let's look at some examples.
Four main transformations that we cover in Algebra 1 and Algebra 2 are quadratics, exponential functions, absolute value functions, and logarithmic functions. And as you can see, the transformations appear in the same place using the same variables in every equation. It's also important to notice that it's always x minus h. When you're translating left and right, it's always subtracting originally, so you go the opposite direction. We'll see two different examples of this in a minute, but it's always important to remember that because the original formulas are subtracting, that you go the opposite direction. In our first quadratic, we have all four transformations happening. Now, when you move quadratics, it's easiest to look at the vertex and move it around with the vertex. The vertex always starts at the origin for the parent function of a quadratic. First, with that negative, we're going to reflect the parabola across the x-axis. Then the 1/2 compresses the parabola, making it wider. We have x minus 7, which again, it's already subtracting. So because it's subtracting a 7, a positive 7 was substituted into the equation. So we are still going 7 in the positive direction, which is right 7 units. And we have plus 1 at the end, which means it's translating up 1 unit. Finished quadratic, and this is also considered the vertex form of a quadratic because it gives you the vertex, the h and the k. The 7, 1 is the vertex of this quadratic. In this next quadratic, only two transformations are happening. And again, we're going to start with the vertex and move from there at the origin. We have plus 6. Now, it was originally subtracting. So the reason why it says a positive 6 now is because you subtracted a negative 6. So we want to go 6 units to the left. 1, 2, 3, 4, 5, 6 in the negative direction. And then we have minus 9 at the end. So we want to go down 9 units in the negative direction. And this is your transformed quadratic. Next, we're going to do an exponential function. For this one, you can move it using the y-intercept and the horizontal asymptote. The y-intercept is always 1 on the y-axis, and the horizontal asymptote is always y equals 0. Now we have two transformations happening to this. We have x plus 3, which means we're going to go 3 to the left. Moving again the y-intercept, the horizontal asymptote has not moved yet, and then we're going to go 5 units down. That's going to move the horizontal asymptote with us. And this is our final transformed exponential function.